just joined us. So ignore my awkwardness. Okay, now we're going to program our own simulations. So write this down. Simulations require two things: repetition. Let's see our first example. So in this block of code here, and don't worry if it looks like a lot, it is a lot, okay? And we'll break it down. But in this example, we want to model a coin flip with 50 repetitions. See, there's our repetitions there. And a 50% probability of heads or tails. And that would be our probability. We have both components in place. So I want to flip a coin, and I want to flip it 50 times, and what I'm going to do is keep track of the number of heads and the number of tails I have, given that we have a 50% probability of getting each outcome. So let's break it down one line at a time. I'm going to call this line 1, 2, 3, 5, 8, 9. Okay, so on the first two lines of code, actually, let me start with this question. How many variables are we keeping track of in our program here? Again, how many variables are we keeping track of in our program? How many do you think? You can feel free to just jump off of mute. So what are my variables? Guys, come on, talk to me. Heads. The number of heads is something that I want to keep track of. Also the number of tails. There's one more variable besides lines 1 and 2. Coin flip. Yes, coin flip is that third variable that can take different outcomes. So I'm going to keep track of the number of heads, I'm going to keep track of the number of tails, and I'm also going to keep track of the value of a single coin flip. Okay, so let's again go line by line. On line 1 and 2, I'm initializing heads and tails, the number of heads and tails, to 0, which makes sense because I haven't started yet, so how could I have any results yet? On the third line, I'm implementing a loop, and each loop represents one coin flip, and we're going to repeat it 50 times. So that is my repetition. On the next line, I introduce a new variable called coin flip, which will take the value of this random number generator. And this is the pseudocode used on the AP exam, so this is exactly how it would look on a multiple choice test. Rand 0, 1 works like this. This is going to output a number that's between 0 and 1 and only integers. So it won't give us 0.5, it won't give us 0.68. That would be infinite possibilities, right? If we could be in between. It's either going to be 0 or 1 or any other integers between. There are no other integers between, so it's just going to give us 0 or 1. Okay, so this, if I keep pressing go, 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 rand 0, 1 will produce 0, 0, 1, 0, 0, 1, 1, 1, randomly just 50 times. And on each iteration, coin flip is either going to take 0 or 1. So let's say on the first time it takes a 0. What happens next? So on the next line, if the coin flip equals 0, which in this case it does, I'm going to increment heads, num heads, by 1. So the number of heads went up by 1. So what does that tell us? It tells us that 0 represents a head. The other thing next that will happen is if coin flip equaled 1, which it doesn't because it's 0, so I'm not going to even go into the next line. And then we would get to the end of our repeat block, and so as you all know, we would go back to repeat and do it again. So this time coin flip gets another random number, 0 or 1, and let's say just by chance it's 0 again. So again, this is true, and num heads is updated this time to 2. I check, is the coin flip equal to 1? It is not. So I skip that line and repeat again, and on this third time, let's say it gives me a 1. Now what happens? Which line will execute? Line 5 or line 7? Coin flip now equals 1. Which line will execute? Line 5 or line 7? All right, line 7 will execute. It's going to check, is the... Okay. This time, look at line 6. What's the difference? Feel free to come off of mute and jump in whenever you have, whenever it strikes you. What's the difference between this and the last program? Lines 1 through 5 are the same. What did I do differently? Who wants to be brave?
Here it has the number of tails be subtracted by the number of heads. So I think that what's going to be displayed is the number of tails.
Yeah, so actually, Sarah, great observation. The one thing I want to say is we're not talking about what's being displayed. Just ignore this. That's like me being a bad teacher. I didn't even tell you what's being displayed, right? Forget about that. What's different about the code itself? Why is this different from the previous example? Here's the previous one for reference. Do you want to try again, Sarah?
Can I look at the new one again?
Yeah, so notice here lines 7 and 8. Everybody. I'm saying else increment tails by 1. Now I'm replacing that with just one line outside of the loop.
So this one doesn't have like a num's tail in the loop. It uses the number of heads value to get to the conclusion of how many number of tails there are.
Yeah, it's not even keeping track of tails every single time. That's really important because it's way more efficient. Let's look back one more time at the previous example. Over here, every single only doing computations when num heads. Look at what's inside the loop. Only num heads gets up. Let's just count 1. And in the last step, however number of heads we have, subtract that from 50. That has to be the number of tails. And so what I've just done is eliminated another half of the computations that I have to do, making this much more efficient than my previous program and like way more efficient than the one before that even. So the goal here is to show you multiple ways that you could perform a program while looking for opportunities to increase efficiency and reduce complexity. This is much easier. It's very simple. Like if you're explaining this to a 10-year-old, you're like, hey, I'm just going to count how many heads we have. And at the end, we'll figure out the number of tails through subtraction. Okay. All right, this one, moving on. So, I hope everyone is okay there. By the way, one thing I did not mention, which is like actually very important, is that this does preserve our 50-50 probability. And the reason and the way it does that is, remember, coin flip can take only 2 values, right? Coin flip can be 0 or it can be 1. Let me give my computer. And then the same is true the other way. Only if I get a 1 will I get tails. A little clever here. Okay, but I'll walk you through it the first time. So now I'm going to upgrade to 1,000 repetitions. And you can see that reflected right here. I'm going to repeat this now 1,000 times. And like before, we're only going to count the number of heads because that's more efficient. But we want the same 50% probability of heads or tails. Let me... 1,000 repetitions is reflected here. But we still have a 50% chance. And let's see how. Now, coin flip can take any random number from 1 to 100. So before coin flip was giving us 0, 1, 0, 1, 1, 1, 0, 0. Now it's going to give us numbers between 1 and 100. So it's going to say we have a heads. So add 1 to the number of heads. Is that 50% still? Well, less than or equal to 50 means I could be 1, 2, 3, all the way up to equaling 50. So that means that I have 50 ways that I could get heads out of 100 total. So I could use 0 and 1, or I could use 1 and 100. And I'm showing you that you can use very different methods to get the same outcome. Let's look at the one on the right. You guys type in the chat yes or no. Does B also give us an accurate coin flip simulator? Yes or no? Elijah, I saw your answer first. Tell us why you say yes. Walk us just a little bit through the logic that you used.
Well, for the coin flip, I saw that there's only two options, so it's a 50-50 chance to roll each number, and you're only choosing one, so that's why I chose yeah.
Very good. This time, coin flip can take, again, only two numbers, 4 or 5. And only one of them, 5, will result in a heads, which again represents a 1 in 2 chance. So we have two options total. So the total will always be the denominator. And then how many give us our true? How many make this statement true? Only one, the number 5. And so that's 1 out of 2, 50% chance. Good job, guys. Now, why would anybody do this? Like, that would be pretty horrible as a programmer if you said, let me choose the numbers 4 and 5. That's very confusing, right? So we would never actually write that, but it is correct. It's just not nice. Also, this is correct, but it's a little overcomplicated because as we saw before, we could just use 0 and 1. And indeed, when there are two options, we usually will use 0 or 1. All right, any questions on this one, the 4 and the 5? Or are we good? Thumbs up if we're good. Question if you have a question. We're going to get into some more complex ones, so please make sure you're really good. Jared, Yoselin, Tali, Rosario, I'm sorry, you're my teacher. Okay, Ariadna, Amy. All right, I trust y'all. Next one. Now we're going to move outside of the coin flip domain and let's talk about simulations for, let's say, the number of days. So we want to calculate how many days it will rain in 1 month with a 10% likelihood of rain. So if I want to see how many days it will rain in a month, how many times do I need to repeat the experiment? How many times do we need to test this possibility? 30 times, right? Once for each day. It either rains or it doesn't rain, and it's going to happen 30 times. So that's why we're going to repeat 30 times. And you see that here and here. And once for each day. And let's look at our condition. It says the day's weather, okay, the rainy day. My question to you is, does that accurately represent 10%? Come off of mute because I can't see the chat. What do you guys think?
No.
Why not?
Because if you get 10%, the number, like the value of numbers 1 through 100 doesn't matter. It's just if you got 10 out of 100 numbers.
Okay, let's slow down a little bit. I want to ask you some questions, okay? So if the day's weather is less than or equal to 10, so which one? So if it's less than or equal to 10, we're going to say it's a rainy day, right? So what numbers count for a rainy day? Give me a list.
1, 2, 3, 4.
In 100 chance of getting rain?
Yes.
Do you want to change your answer?
Yeah, I was thinking before, like the value of the number, but yes.
Okay. So I wonder if probably other people were thinking the same thing, Charlie. So that's why it's really helpful to go through that together. So out of these 100 possibilities, 10 of them represent rain. So if I get the numbers 1 through 10, I have rain. If I get the numbers 11 through 100, that's 90 ways that I could get no rain. So hopefully it's clear now that we've gone through this exercise, that represents our 10%. So this is check mark, accurate representation of the number of rainy days out of 30 given a 10% chance. You guys now look at B, and I want you to think of look at it the same way. Does B also give us an accurate representation of the number of rainy days? You type in the chat, yes or no. This time, let's hear from Amy. Amy, tell me why yes, if you can explain it. Then you really know it.
It's because it's 1 out of 10, so that's 10%. B from 1 to 10. If you select 1, then it's 1 over 10, which is 10%.
Beautiful. Well said. So in this case, only 1 out of the numbers, 10 total, 1 out of 10, will give us a rainy day, and 1 out of 10 is 10%. Awesome. Let's look at a couple more examples. Okay. You guys tell me, so you're going to write in the chat A, B, none, or both. Which of these represents another accurate simulation for a 10% chance of rain, 30 days, counting the number of rainy days? You write down A, B, none, or both. Don't hit enter until I say go. Ready? We'll give everybody a chance to think. Psst. Focus on the total number here. Write them out if you have to. And then look at the condition. Again, the total numbers and then the number that makes it a rainy day. Let's take 20 more seconds. You're going to type in the chat A, B, none, or both. All right, 5, 4, 3, 2, 1, 0. Let's see your answers in the chat. All right, I'm seeing some nones. I'm seeing some boths. I like how nobody was like, one of these is fine. It's all or nothing with us here. Okay, a few of you have still to respond. Make up your mind. Okay, the answer, guys? Well, let's work it out. So, how many different values can the day's weather take from 0 through 9? That's going to be 10 values. So again, we have 10 possible values, and the only, so 3, if I get a 3, that's 1 chance of having a rainy day out of 10 chances. If you think of each of these as a chance. And again, nobody would actually do that in a program, but I just want to make sure we're understanding conceptually what's going on. And if somebody wrote that, I mean, it would be right. It would just be weird. Why did they choose the number 3? And for that matter, I could have chose any number. I could have said if it equals 7 or if it equals 9. And indeed, if it equals 10, by the way, 3 represents one of those 10. Now, on B, if it had been 1 through 10 without a 0, and we said let 10 be the rainy day, again, that's a 1 chance of rain, and then 9 chances of not rain, so that's a 1 in 10 total, another 10%. So the answer there was both. Clearer, and if it was clear, give me a thumbs up. So for those of you who had said none, I hope that it makes sense now. Okay. So now I want you guys to find the error. In this program, I'm trying to simulate how many times a person will roll doubles when rolling 2 dice, and they're going to do it 100 times. So to roll doubles means you have 2 of the same number. So 3 3 is a double, 1 1 is a double, 6 2 is not a double. Find the error. I'll give you guys a minute to look at it, and this is a pretty tricky problem. It took me a minute to figure it out this morning when I was looking at the slides and getting ready for the day. So be comfortable taking your time on it. I'll give you guys a minute or 2. What is the error in this code? Here's a hint too. Actually run the program, like write stuff down and see what happens. We want to count how many doubles will be rolled out of 100 trials. So on line 1, we're going to keep track of the number of doubles, of course, starting at 0. And only if dice 1 equals a double. It all seems very good. So what's the problem? Let me number these. 1. Okay, come off of mute. Anybody who has an answer for me? Tricky, huh? All right, we're going to do a simulation together. We're going to run through it together. So line 1, we're going to initialize doubles to 0. In line 2, dice 1 takes a random number between 1 and 6. Let's say, I don't know, it got the number 3. On line 3, we're also going to let dice 2 take a random number. Let's just say, by chance, it also got a 3. Just, could be whatever. You could pick whatever numbers you want. The important thing is we're trying the program. Okay, now we're going to repeat 100 times this block of code. So what are we going to do next? We're going to check if dice 1 equals dice 2. Guys, does dice 1 equal dice 2? Sure it does. So what are we going to do? If this is true, we're going to say we have a double. So doubles becomes 1. Now, what line of code do we go to once we're done with our repeat block? Keep doing line 5 and 6 100 more times. So now I'm going to check on line 5, is dice 1 equal to dice 2? Well, of course they're equal. They were equal last time. They're still the same numbers. So it's going to say, yeah, we have another double. And then it's going to check again. They're still equal. We have another double. Guess what this program's going to tell me? It's going to tell me that out of 100 trials, I had 100 doubles. What's wrong with my program? What would you change? Anybody off mute?
Move the repeat 100 times up to in between lines 1 and 2.
Yeah, we actually want not just to check 100 times if the dice are equal, but we also want to roll the dice and get new values for them as part of our repeated trial. So you could say, let's move line 4 up. You could also say, let's move line 2, get random values. It's very important that you give new values inside your repeat block. And then you can... Okay, you guys tell me. So what we just did is we looked at A. It's the exact same thing we just did. Look at B. You tell me yes or no. Does it do the same thing as A? Or does it give us a different result? So think about it. Does version B give us the same solution of simulating the number of doubles out of 100? The only difference is this line. I'm going to check if dice 1 equals dice 2. So if like they're 3 and 3, it's going to give me a double. And this is just saying take the 2 die and subtract them. If they equal 0, you have a double, which makes sense. If the two numbers are the same, then when you subtract them, you should get a 0. It's another way you could check if you have doubles. Of course, if you have different numbers. So now the question is, which version? So they're both correct, but which version is preferable? Which one is more efficient? Type in the chat, A or B. Which version is more efficient? Who wants to come off of mute and tell us why A is more efficient than B? You're right, but why? And as a clue, when we're talking about efficiency, an easy way to think about it is the number of computations that you have to do. Anyone want to take a stab at it? Why does A have less computations than B?
Because it doesn't have to calculate the subtraction.
Yeah, Matthias, exactly. Because on A, it only does one computation. It says, are these equal? And then it gives an answer. It moves on. Here, it says, what is dice 1 minus dice 2? So there's a subtraction. Then it checks, is that equal to 0? So hopefully everybody sees that the right side has double the number of computations as the right side in terms of that check. Here we have one computation, the equal, the comparison. Here we have two computations, subtract and then compare. So A is more efficient. What was that fancy phrase that I used when something is less efficient? Who can finish the sentence? It's computationally what?
More expensive.
More expensive. Yeah, it's going to take, and more expensive in terms of time. It costs more time. It costs more memory. It's more expensive in a bunch of ways. Cool. Okay, next example. Now we want to do a simulation for how many times a person will roll snake eyes. Snake eyes means that you have a double, but they're both ones. So a 1 and a 1. That's what a snake eyes is. So 2, 2 is not snake eyes. It's got to be a 1 and a 1. So here's the code set up for you. We're going to initialize the number of snake eyes to 0. In the second line of code, we're going to repeat this 30 times because we want 30 trials. And of course, inside the loop, we set the values of dice 1 and dice 2 to numbers between 1 and 6. What's next? Aha, we have to make a decision. So what goes in here? What is the missing code that should go here to tell me we have another snake eyes? I want you to think about it. Don't write anything yet. Here are your options. I want you to select all that apply. But don't hit enter until I say go. Let's give everybody a chance to think. So which of these is going to give us the snake eyes? Yes, which of these conditionals? Take 20 more seconds, and again, select all that apply. There might be more than one. Three, two, one, enter. What answers do we have? It looks like a lot of us are choosing A and C. Some of us are choosing A, some choosing C, and then all over the place. Okay, so let's begin. I want to start by saying yes, A is correct. If you want snake eyes, definitely dice 1 has to equal 1 and dice 2 has to equal 1. That's correct. And the and here makes sure that both are true, not just one of them. If I had said or, this would be incorrect because then it would count as snake eyes even if I got like a 1 and a 5 or a 6 and a 1. Or means only one needs to be true. So we need to have the and there. You know what? Next time I do this, I'm going to do D where it says an or in the middle. Now that would be a good problem. Okay, next, B. Who can tell me why B is incorrect? Just come off mute. Give me an example that proves that B is wrong. And let me start off by saying why I would think it's right. Okay, so you argue against me. So B is right because if you have a snake eyes, dice 1 is 1 and dice 2 is 1. And if you subtract them,
if you had dice 1 is 5 and dice 2 is 5, and you dice 1 minus dice 2, you'd also get 0.
So you're saying if I had 5 and 5? Is that right?
Yeah.
So if I have 5 and 5, we only want 1 and 1, not 2 and 2, or 3 and 3, or 4 and 4. So this is wrong because it's actually counting doubles. All the doubles. Anytime dice 1 and dice 2 are equal, it's going to count as snake eyes, and that's not what I want. C is also correct. You know what? Who can tell me why C is correct? Come off of mute. How about we have a lady? We haven't had a lady talk in a while. Ariana, Tali, Amy, Yaslin.
If you were to add any other value, for instance, 1 and 2, it would equal 3. The only values that will equal 2 are 1 and 1.
Yeah, the only values that will equal 2 are 1 and 1. What about like 0 and 2 though? That's
0 is a value.
Yeah, 0 is not a value that's assigned, right? So keeping in mind, we're only taking numbers 1 through 6. The only way I could get 2 is if both of them are 1s, because there is no 0 value on our dice. So I was trying to trip you up. Good job. And so that's why A and C are both correct. You guys are really doing great. So we have a few minutes left, and in these few minutes, I want to actually write the code ourselves now. We've looked at a lot of examples, but let's do our own. So please write down, it doesn't matter what number it is, just write example, example, example. Probability of A is 50%, probability of A is 10%, and then write down probability of A is 60%. And the way that we pronounce this, as ejects, But the way we pronounce that out loud is not P parentheses A, it's probability of A. Okay, so here's how we will approach these problems. If we're given a probability, in this case 50%, use a fraction out of 100. So the first thing we're going to do, and if you're not paying attention, you're going to be very lost, is we're going to rewrite this as a fraction out of 100. Next, we're going to simplify. So 50 out of 100 can simplify to 5 out of 10. It could also simplify to 1 out of 2. So it could also simplify to 30 out of 60, right? Or 15 out of 30. These are all the same as a half. But for right now, let's just focus on the most simple version. So the number at the bottom is going to be represent the total, okay? So that means that trial, being like the weather of the day or the outcome of a coin flip, needs to have, in this case, 2 possible outcomes. So if I choose 1 and 2, that's going to give me 2 possible outcomes, either 1 or 2. I could also choose 0 or 1, being 2 possible outcomes. Next, what goes in here should represent the numerator, number of outcomes. So in this case, I want only 1 out of the 2. So if I say equals 0, well, out of 0 and 1, only equaling 0, there's only 1 possibility there. And so I have a 1 and 2, or a 50 out of 100, or a 50% chance. What else could I write after the word trial here to also get a 50% chance, you guys? Mute, unmute. I could write equals 1, right? That's another way I could get 1 out of 2. Okay, let me briefly show you another way you could do this. It's true. Okay, there should be 5 ways to make this true. So less than or equal to 5 should work. So here I need to represent 100 values. Jump off of mute, it'll go much faster. What could I put in these parentheses now?
1, 100.
And yeah, perfect. And then I need 50 ways of getting this trial. So what could I write in here?
Less than or equal to 50.
Beautiful. So 1 through 50 will be true, and then 51 through 100 will be false, and that's 50-50. Okay, let's go to the next example. Probability of A is 10%. So try doing it yourself, but I'll guide you. First thing we'll do is always rewrite this out of 100. Next, let's simplify the fraction. That can simplify all the way down to 1 out of 10. So this time, let's hear from Matthias. What could I write in here? In the top? I want a 1 out of 10.
1 comma 10.
And how will I get only 1 possibility here?
If trial is 1.
Equal to 1. Very good. 1 is the only one that counts, and then 2 through 9 don't count. Awesome. Let's do the next one. Probability A equals 60%. Yoselin, guide me. What should I write down first? What are the steps that we're doing? Yoselin, are you there? You might be muted. Okay, I'm going to take us through. So 60 rewritten out of 100. Next, guys, how can we simplify this? Everybody on mute. We're going to do like we're in class. What do I do next? We can take this a couple steps. Yeah, what comes next?
6 out of 10.
6 out of 10. Can we simplify further?
Yeah, 3 out of 5.
Beautiful. So 3 out of 5 is the most that we can simplify. Guys, the denominator is the number that goes here. So I need 5 possibilities. What am I writing in my RAND? I need this many possible outcomes. So 1 to 5. Everybody okay? That's going to give me 5 options. Now I want 3 of them. 3 of getting it right. Greater than 3 is going to be 4 and 5. Careful. So not greater than 3 and not even less than 3. Less than 3 is only 1 and 2. That's again only 2 out of 5. How should we rewrite this inside? Yeah. How about less than or equal to 3? Boom. Now I have 3 out of 5. And that's the probability that I want, 3 out of 5. I could also write greater than or equal to 3, which would give me 3, 4, and 5, which again represents, okay, thumbs up or thumbs down, you tell me. Let's do another one. Ready? Example 7. Okay, we're going to breeze through this. Please, guys, come off of mute. More than one. In Arabic, we say yalla, means come on, hurry up. Yalla, yalla, yalla. Who's going to unmute? Charlie's unmuted. Who else?
5 out of 100.
¿Quién más? Elijah, unmute. Jonathan, unmute. Sarah, unmute. Angel, unmute. Come on. Good. Okay, guys, shout out for me. What do we do first? It's 25% here.
Write it over 100.
Okay, and let's
1/4.
Okay, 1 out of 4. So, guys, these are the same 2 lines as before. Don't get confused. I just added the other stuff, right? We initialize our variable, we repeat some number of times, and in the end we update our variable, but we're going to still focus here and here. So what will go in my rand? What are the total possibilities that we want? Between
We want 4 possibilities, so it would be 1.
trial
1.
equals 1. What if it was trial greater than 1? Would that work?
No.
Why not? Be great. Let's do the next one. Number 8. I'll do this one. Ready? Percent. Hint, it doesn't simplify. So see if you can fill in the rand in the trial. Check your work. Did you get it? So I want 100 total options. And then to count 47 of them, I will take numbers less than or equal to 47. So 1, 2, 3, 4, 5, all the way up to 46 and 47. That's going to be 47 out of 100. Okay. Now we'll do, we're going to take 5 more minutes to finish because I want to finish with an actual AP question. So here is your warm-up for the AP. Ready? Here I want to simulate how many earthquakes will happen in 1 year. Key word. The probability of an earthquake on any given day is 3%. I'll give you 2 minutes on this. Select 2 of the options that give us a simulation for a year's worth of earthquakes, given that the probability is 3%. So you'll type your answer in the chat, but don't hit enter until I say go. One more minute. Okay, let's see the answer. Wrong, because it's only the number 3 is going to work. So that's only 1 chance of having a quake out of 100. So that's only a 1% chance, which is wrong. C is correct because less than or equal to 3. So it's going to take 1, 2, and 3 being earthquake days and the rest being non. So that's a 3 out of 100, which is a 3% chance. Good job with C. Why is B wrong? What line of code is the error on? Line 2, right? It's only repeating 100 times, but we want to simulate a year, so we need to do it every day. 3% chance that it quakes, 3% chance that it quakes every day, 365 times. And D is correct because 98, 99, and 100. It says greater than or equal to 98. So 98, 99, and 100 represents 3 quake days out of 100 total. Well done. Now you're ready for your first AP question. Ready? Here's a minute on the clock. In a certain district, 20% of the voters are expected to vote for candidate A. Psst, you should probably write this down and do what we've been doing with that number. The computer program below is intended to simulate the result of an election with N voters and display the number of votes received by candidate A. Which of the following can be used to replace missing condition in line 4 so that the program works as intended? You're going to select 2 answers and write your answer in the chat. Don't hit enter until I say go. Thirty more seconds. Five, 4, 3, 2, 1. Enter. Okay, let's look at why is A. A is correct. Okay, so it's saying, hey, let's check if a random number between 1 and 5. So instead of doing it on 2 lines, it's doing it on the same line. And that's okay. So a random number between 1 and 5, and only if it equals 1 will we add to the sum, which is the number of votes that the candidate is getting. And that represents a 20% chance. By the way, hopefully the first thing you did was write 20 out of 100, which is 2 out of 10, which is 1 out of 5. And so A is correct because it gives us our 1 out of 5. C is wrong because out of 10 numbers, only the number 2 works. If you imagine. Because out of the 10, both 1 and 2 give us a vote, representing 2 out of 10, which is 1 out of 5. Good job. And last one for fun. Why not? Let's see this. A visual problem. Ready? Okay, this is like the culmination of all you've been working toward today. A spinner is divided into 3 sections. The sector labeled red is 4 times as large as the sectors labeled blue and yellow. The procedure is intended to simulate the behavior of the spinner. Which of the following can be used to replace missing code so the procedure correctly simulates the spinner? Ready for the answers? Select 1. 1 minute on the clock. Ten more seconds. 5, 4, 3, 2, 1. Okay, here are the results. Most of you selected, whoops, there are the results. Most of you selected D. Let's talk about why C and B are incorrect. So the problem with both A and B is that spin is taking a random variable between 1, 2, and 3. So let's look at B, for example. If spin is 1, it's going to give us yellow. So that means yellow has a 1 in 3 chance of being selected because there's 3 options and it's one of them. And then blue is only if you get 2. So if I get the number 2 out of the 3, that's again another 1 in 3 chance of being selected, leaving us basically with only the number 3 giving us red. So a 1 in 3, 1 in 3, 1 in 3. That is what this spinner would do with equal each. The correct answer here is D, because it gives us a 1 in 6, which if you actually, they were telling you, you know, this one is 4 times as large, and if you drew it out, you could see that red has like 4 times the size of blue and yellow. So if you count it up, that's actually 6. Okay, red has a 4 in 6 chance, yellow has a 1 in 6 chance, and blue has a 1 in 6 chance, and this is the only one that does that. So out of 6 numbers, only if I get the number 1, which is a 1 in 6, will I get yellow. Only if I get chance. And that is your lesson for today. I hope that that was helpful. And if it was, let us know in the chat is your evaluation. And if it wasn't, also let us know, because your instructors want to improve. I had so much fun with you guys. Thanks for participating. Let me know how it went. And then have a great day. Thanks for sticking around. Please don't leave until you're done with the form. And when you're done with the form, let me know that you're leaving by saying bye. I would love to hear your voice before you go.
Bye.
Bye, guys.
Thank you.
You're welcome.
Bye, thank you.
Bye.
Bye. Thank you.
Bye, Rick.
Thank you. Bye.
Bye,
You're
thank you.
welcome.
Bye. Thank you.
Bye, Ariana. Bye, Angel. See you guys.
All right, finally working. Bye.
Yay.
Thanks for the.
You're welcome.